Hi, and welcome to openIMIS Developer Training Sessions. I'm Xavier from Blue Square, and this session is dedicated to introduce front-end development. The front-end responsibility is to implement all user interactions. So first presenting data to the users, but also reacting on button clicks or filled-in forms, things like that. The front-end is connected to the backend from which it fetches the data, but also submitted changes. Please refer to Modular Architecture Overview video to understand the various parts of openIMIS and how they relate. The documentation for the software is in openIMIS Wiki, so please refer to it for up-to-date and more detailed information. This session starts with some prerequisites, so what is needed on your computer to start developing on the front end. Then we set up the development environment itself to create a first simple module and connect it to the backend. But let's first have a quick recap of openIMIS architecture. openIMIS is a three-layer software, so relational database, backend, and frontend. The backend and the frontend are based on contributions and events. So this training session will illustrate how events and contributions are used in the frontend. To develop in openIMIS frontend, we recommend you to install openIMIS database and backend locally. This way you will fully control your environment and be able to develop in isolation from any other developer. However, it is not mandatory. You may want to share a backend and the underlying database with other developers. To do so, you need a straight access to the backend, so without the openIMIS gateway security. Please refer to openIMIS backend development video to reach this point. To develop in the frontend, you will need Node.js, a JavaScript code editor. In this video we use Visual Code, Yarn, and Git. Let's zoom now in the front-end web application. The front-end is an assembly of modules, so it first requires a container to manage the assembly itself. This container is provided by the openIMIS FE frontend_js GitHub repo. So let's clone this repo in an empty local directory. You can here use the HTTP access if you like to. For this tutorial, I will switch to Develop branch. Indeed, with 1.2 version, we just did a major technical upgrade, which is right now in preparation, but very soon on the master branch. So make sure you are at least on a 1.2 version before continuing. First, we need to install all openIMIS technical dependency. Depending on your internet connection, this may take a while, so I will pause the video and come back when done. So here we are. At this stage, we have an empty container, and we need to install openIMIS modules. The list of modules depends on your installation, but there is one module which is required. It's the core module. That's the bootstrapping point of the application. As bootstrap module, the core module will provide the main menu, to which all other modules can contribute. Modules can also contribute to each other. Modules have their own GitHub repository, so we will go outside our application container and open our code editor from here. So for now, our Visual Code editor only contains the container application. The container application lists the deployed module into its openIMIS.json file. That file will be modified according to your deployments. The current list of modules represent the openIMIS default implementation. So we will be modifying this list according to our needs. But first, we need to install the reference modules. The openIMIS container provides an openIMIS config script that is dedicated to inject the configuration into the application. To make it run, we just enter the container and invoke the openIMIS config file. This configuration script prepares the container to load all modules, but also prepare a configuration file to help installing them technically. So let's invoke this install file to install all openIMIS modules that are needed locally. Depending on your internet connection, this can take some time. At the end, you can always list the installed module to ensure you have the proper version. So in this case, we see that we have all these modules installed with the 1.2 version. Before launching the front-end application, please ensure your backend is running locally on port 8000 and with API as site root. So the GraphQL API should be available at localhost 8000 API GraphQL. With that URL available, you can start your front-end server with yarn start. Depending on your computer performances, this can take some time, as the container has to assemble all downloaded modules into one application, which is now available on port 3000 of your local host. In development mode, the local application bypasses the gateway security by setting the remote user to admin or user 1. Also in development mode, all screens that are proxy to the legacy application, such as the home screen, remain empty. The new modules are there available. Let's play with the list of activated modules. And as a first exercise, remove all modules but the core, which is mandatory, and the home to still have something to display. So back in our openIMIS.json config file, I will remove all modules but the core and the home. As you can see, the openIMIS.json config file is outside the source code of the application. So to configure the module manager within the source code of the application to take the new list of modules, which is shorter, you need to run the config file one again. By doing so, the openIMIS application recompiles, and here just has no module anymore activated but the home page. And so the main menu is created by the core as well as the drawer, as we will see later on, but there is no other entry point on the menu. Let's now reactivate one of the reference modules. So back in our openIMIS.json config file that contains the list of activated modules, I add the claim module and activate it in the module manager. So the development server recompiles the application and now displays the claim main entries. Let's do it once more with the claim batch module. So adding it in the openIMIS.json config file, activating it in the module manager, so the application recompiles, and when ready, the claim batch menu entries are readily available. So the claim batch menu entries contribute to the claim menu, not to the core main menu. This is one example of a module contributing to another module's entry. Before continuing, let's revert to the openIMIS reference implementation with the default reference module installed. By reverting our changes in the config file and activating them with the module manager. Now that we have seen how to retrieve the default module list of the reference openIMIS implementation and reactivate them according to our needs, let's look at how to create a new module. Here is a quick overview of what is needed to get a new module. We will start from a template module, which we will adapt to our need. Then we will install the module technical dependency and create a link. Finally, we compile the module. Then from our openIMIS application, we will use the link, the created link, to install the module locally. And as any module, we will register our new module in the openIMIS.json config file so that the module manager will load it. But let's do it step by step all together. First, we need to go back to the root of our development directory, so we don't work from within the openIMIS container application. and we will clone the template module next to the container application. So the container application and the modules are next to each other. We don't want to keep template as a name. So we will first rename the template to our needs. Please note the naming conventions: openIMIS dash frontend module and then the name of the module with underscores and underscore JS to indicate that it's about JavaScript. Now we need to adapt the content of the template to match our module name. So from within our code editor, so we now have the container application and the new module next to it. We open the package.json file and adapt the name. You can also adapt the description and the repo to which it will be published. You will probably want to adapt the readme.md file also, but this is not necessary for the purpose of the exercise. Each module is loaded from its index.js file. So to ensure that the module manager loads the module from its name, let's rename this all together. The content of this file will be adapted as we develop the module, but for now, this is all we need to have a running module. So once the source code adapted, we now have to make our module ready to deploy locally. So we will install the module dependencies, create a link, and compile the module. The modules are compiled and packaged independently from the container application. So to compile the module, we go into that module directory. We install the module technical dependencies, and we can compile by starting the module. So this is a difference between the openIMIS application. Within a module, the configuration is the rollup configuration, and a yarn starts a process that always compile the module and listen to the change into your directory. So at this stage, the compiler waits for change into the module directory, recompile, and prepare the module within that module directory. So to install it in our container application, we will create a link to that package, and within our container application, we will use that link. So now the container application has a reference to our module directory as if it was downloaded from npm.js as for the reference modules. So the next step is to activate the module in our container application. So to do so, we go back to our openIMIS.json config file within our container application, and we add our module to the list of modules. Please note that the module name has to match the module name exported by the index.js file. Here we can now run our config script to ensure the module manager loads the new module. So now in the list of our modules, we can see our new my module in the list. The module doesn't do anything yet. It doesn't contribute to any other modules, nor the main menu from the core module. The first thing we will do with our module is contribute to the main menu. So our module will add a new main menu entry as a contribution to the core main menu. So let's go back to our development environment and start creating content in our module. The structure of your module is your own choice, but the reference modules used to have their main menu entries in a folder called menu. Here we will create a React component called myModule and this React component will look as follow. So first it is a React component which renders as a main menu contribution. So the main menu contribution is a component from the core that is made to ease creating main menu entries. Main menu contribution is a list of entries which are made of a text, an optional icon, and a route. This list can be dynamic, so based, for example, on user rights. So it's always good to check that there are indeed entries in your new menu entry. So now we can save our component and we need to register to the main menu contribution of the core module. This is done in the index.js file. In the index.js file, we first need to import our component and register it as a contribution to the main menu. When saving our index.js file, the rollup config of our module will detect the change and recompile. So the module is now recompiled again into the dist directory, and thanks to the yarn link setup, the container app also will detect the change in the module distribution directory and recompile the whole application. So by this way, we now have our new module entry with my module, which is obviously not what I wanted. So let's go back to our development and see that the header should be my module, while the entry should be my entries. Compile the whole loop and then back to the. Now, when I click on this menu entry, the invoked route is the one mentioned in my component. There is nothing registered to that route yet, so let's register a page to that route. Also, as a convention that you are free to follow, the landing pages, so the one invoked from a route, are created in a pages directory of your source code. So let's create in that directory a JavaScript component which will serve as landing page. Okay, so the name has to be with only one extension, JS extension, and the content is a usual React component which display a div and my entries. So here we can also see that the class name, so the style, is applied from the theme.page. So this allows us to have the same CSS theme for all pages. So now we can save our React component and we need to register this component as the one being activated by the root of our module. So this is done in the index file also, where we will first import our React component and register it to the router. So we used to have our routes declared as constant and we add it to the as a contribution of the core router. So the core module contains also a router to which you can register component based on the routes they follow. So if I now save the index file, the module compiles, the application recompiles, and now starting from my module, my entries, I have the my entries page, which only contains my entry. So to sum it up, we have created a new module that adds a main menu entry, which contains one entry with a route to my module, my entities. To that route, our own module registers a page which displays my entries. So this is all done dynamically thanks to the yarn start in the module and the yarn start in the application. So if you change the page content to your needs and save, all the compilation goes in the background and display the change. Before connecting the module to the backend and actually fetch the entities, let's look at how we can make the translations. Starting with translating the menu entries So within the current implementation of my module, the my module menu entry and the my entries within that module are hard-coded in the module code. We want to remove those strings from the code and have them managed by the React Intel package. So first, let's import that package and inject the internalization mechanism to our module. So the inject Intel creates a new property of the component, which is called Intel. So the rights property is for later. It's to manage user rights. I will come back on this later on. It's not necessary right here. So now we can use the format message helper method, which is located in the core module, and invoke it to have our string translated. So the format message takes three parameters: the Intel, which is injected to the component, my module, which locates the translation into my modules, and the menu my entities to spot which is the message we want to see. In the same way, we can translate the main menu entry. So here again, format my message, Intel, my module, and main menu. When invoking the translation mechanism, you have to provide a default translation for it. So this is located in the index file. As you can see, the translation are loaded from the message English, which are themselves loaded from the English.json file. So let's go into our translation English.json file, which is right now empty, and to which we will add the translations. This translation file follows the standard JSON translation format, which is then processed by localized to add other languages. So in that file, what we need to do is to add our entries, starting with our module and then the name of the entry we want to point to. Let's distinguish them from the hard-coded version and save our translation file. Back to our application, we see that the translation has been invoked. The core module also provides a format message with values, which allows you to create messages with variables. Besides helper methods, core module also provides a React component for translation. So let's go back to our page and use that new component to translate our page content. The component is called formatted message, and you can have a module and an identifier also. You need to import that component from the core module. And provide the translation in the translation file. So the user language is defined by the database. So the link between the user-defined language and the translation file used is made in the container application and is located in the openIMIS.json file in the beginning. So here what we say is that users that have en or engb in the database use the file name with en. The one with fr in the database use the fr files. To provide those files, so the fr.json files, we will deploy language pack modules. So a language pack module, so for example here by default the reference fr language pack module is added as a usual module. A language pack module is a usual module, so it has the same structure as a usual module, but it only provides translation. So if we look at the FE language FR, in the source, we have an index that only provide in the translation contribution the FR and loads the FR messages for the application. So if we look at the translation, it's a huge file and it's generated by localized. Okay, so up to here, we have created a new module, and that module contributes to the core main menu by adding an entry. That entry provides a link to one page via the router mechanism. And we have seen how to translate those with translation keys. Let's connect now our module to the backend and download our entities. As entities, I will use locations. So locations are entities provided by the location backend module. Obviously, you would be creating your own backend module with your own entities. So the locations backend module provide a locations GraphQL API that allows us to query from locations. This GraphQL API is paginated, so let's query for the first 10, and we see that we can retrieve the UIDs, but also the name, for example, of the location. Let's perform the same GraphQL query, but from our frontend module to display the locations to the user. Fetching data in the backend is performed asynchronously, so using the Redux mechanism. The mechanism is twofold. So first we have an action that fires an event. That event triggers the fetch of the data in the background asynchronously. When the fetch call is resolved, so when the data has arrived to the browser, Redux fires also an event to which we can listen to update our page. Let's start with creating our action to fire the event. So we are in our My Module directory in the source, and by convention, I create a file called actions.js. The openIMIS core module provides you two helpers method to fire the event. It's the GraphQL and the format page query. The action itself is pretty straightforward. So we export a function which will create a payload, a GraphQL query based on the location resources. There is no filter, so filtering could be a parameter to tell, for example, to filter on location name or things like that. And you want to retrieve the code and the name from those entities. So the format page query generates the JSON query as a payload, and the GraphQL method dispatches that event into Redux. The event is given a module-specific name, allowing modules to register to those events. Let's now fire this event. We will use the component load of the entities page to do so. So when the component is loaded or mounted, we want to fire the load entities event. The action has to be imported from the actions file. There are several ways to bind our component to the actions. I will use the React Redux component to do so. So first we import the connect and the bind action creators from React Redux. With the connect method, I can connect my component to the Redux container and bind actions to it. Traditionally, the binding method is called map dispatch to props and implemented as a constant of the module. So what we say here is that our component is bound to the fetch entities action and can be called as a properties of the component itself. Okay, so let's save it all and look at what happens when the module now loads the component. So let's open the developers tool to look at what is happening on the network. So it will trigger the refresh of the page, which as usual does the whole job, plus this time sends a GraphQL query to the backend, which is made of the locations query we've just added. The response from the backend is giving us pagination indications, but also the code and the name of our locations. So now what we need to do is to register on the fetch resolution, and update or display according to the response that we received from the backend. This is done by registering a reducer to the Redux events. By pure convention, this is done by adding a file which is called reducer at the root of your module. The module reducer has to be plugged to the application Redux setup. Here again, it is done via contribution. So back to our module index.js file where we record all our contributions, we will add a contribution to the core reducer. So let's first import our module reducer and register it as a reducer of the core reducers. The key here is important because it's a prefix for the state in the reducer. You could give anything as key, but giving the module name is a good practice. So our module reducer is now loaded into the application container, and we need to implement it as a standard Redux reducer. So a reducer is a function which is exported by default from the reducer file and which receive a state and an action. When the reducer is first called, the state is initialized with fetching entities to false, error in my entities to null, fetched entities to false, and an empty list of entities. This will be used in our component to detect when entities are being loaded, when they are loaded, actually loaded, or on if there has been an error while loading them. So our module reducer will now be activated in the openIMIS application and will be able to react to actions. Our module will receive the actions from all other modules and will be able to react on them. So first, we need to tell the reducer that we are only interested in our own module action, and by default, if the action type is not in the list of those we want to listen to, we just do nothing. The first action we want to register to is when the fetch is triggered by Redux. So our action was foreseeing my module, my entities. The framework adds a request when the request is sent. So the _rec is added by the framework. So when receiving this request sent to the server event, what we want to do is to tell that we are currently fetching entities, that any previously fetched entity should not be considered. So we just empty also the list, and that any previous error is also not to be considered. Let's now save it all and look at it in action. By adding a breakpoint in the locations resolution in the backend, locally running backend, I can now stop while fetching the entities. So let's fire it again while loading the page. So the fetching location request remains unresolved for now. You can install the Redux plugin onto your browser, and this way you can actually inspect the Redux state. So we can see that at the key my module, I have the fetching entities to true, which has been set by our reducer. So let's release the backend so that the query returns and we receive the response. So what we have done up to here is to register a listener to the fetch data event of Redux and prepare the state to indicate to the UI that we are currently fetching information. Now we need to register a listener to the data received event. So let's go back to our reducer and react on another type of event, which is the information response or received. When receiving that event, we want to tell the UI that we are not fetching entities anymore. We have received a response and that we indeed have entities. The entities themselves, so the locations received from our fetch query, are in the action payload in JSON format. So you need to parse them to have JavaScript object, and to do so you can use the parse data from the framework. So here, when receiving the entities, you want to modify the state to get the entities from the action payload. When sending requests to the backend, you can have two sorts of problems. First, the HTTP request itself can fail. We will see how to handle this. But also, the GraphQL can send you an error saying the GraphQL query, for example, is not correct. So we need to see if the payload does not contain a GraphQL error. To make it easy, the framework provides you a format GraphQL error helper method. With that method, you can read the error content and add it to the state using the GraphQL error helper method. So if for whatever reason the GraphQL returns a formatted error within an HTTP valid response, this error will be set into the error myEntities state of your component. Now, if the HTTP request itself fails, Redux will send you a specific event, which is called the event name _r. These HTTP errors are, for example, 500 server crashed or timeouts and things like that. So to get the error message from it, you can use the format server error helper method from the framework. So you can add it to the import and register the received HTTP error as error myEntities in the state. Okay, so let's save it all and look at it in action. So I still have my breakpoint in my backend when resolving locations. If I refresh the page, I will trigger the fetch again because the component is mounted to the page. And so the GraphQL query is now pending. As previously, we have in the Redux state, the indication set by our reducer that we are currently fetching and that we should not display any entry. Now, if I release the backend, the second event will arrive, so the response, and my reducer will say fetching my entities to false. There has been no error. I have fetched the entities, and here are the parsed entities put into the state. So we have been into this response event, and we have parsed all the data from the response. Since the data is now in our state, it is just a matter of displaying them to the user now. So let's go back to our entities page and adapt the rendering of the component so that it displays the entities when they are in the state. The first step is to map the Redux state to properties of our component. So this is traditionally done with the connect, first argument of the connect, and a method named map state to prop. So map Redux state to component properties. This is also implemented as a constant of the component. And in this case, we receive the Redux state and we say on the key my module, I map the fetching myEntities entry to the fetching myEntities property of the component. So now my component has 4 new properties that I can use to display the proper information to the user. So let's map those properties to variables. And in the first stage, indicate to the user that entities are being fetched when it is the case. The core module provides you a generic component to display to the user that something is being loaded or display an error in a standard way when there has been an error. So you can use this component as first component of your page. So the progress or error component from the core module takes 2 properties. The progress boolean that indicates whether there is something in progress or not. In this case, we bind it to the fetch myEntities property of the component, which itself is bound to the myModule fetching myEntities from the Redux state. The second property is the error. So whenever there is something in the error, it will be displayed instead of the progress thing. And if fetching myEntities is false and there is no error, nothing is displayed from that component. So let's look at it in action. I still have my debug point and the front end just refreshed the page. We are blocked with the GraphQL pending because of the debug in the backend. So the component is now displaying the progress information. We can check that in my module, the fetching entities is true. So the progress or error display the progress thing. If I release the backend now, the progress or error component don't display anything anymore because it's fetching false and there is no error. So let's now do what we really wanted to do, which is displaying the locations to the user. So back to our entities page. So our module reducer react on the information received event and add the entities into the Redux my module and my entities state, which are now bound to the my entities component property and are now into a variable my entities. So all what we need to do is to actually display the content of these my entities variable. So here I will use a table. Obviously you will be using much nicer components coming from Material UI and things like that. This is just for the example. So if there are entities, I will take each entity and display a line in the table for that entity. So let's run it again and look at it. Obviously need to release the breakpoint, and now I have the table that display the content of the Redux state to the user. Let's have a quick conclusion of what has been covered in this session. We have set up our development environment and installed locally the reference openIMIS implementation with all reference modules. We have activated and deactivated existing modules before creating our own module. We have quickly looked at how to translate our text before jumping into the Redux events, actions, and reducers to bind the front end to the backend GraphQL queries. I hope you found this video interesting and that it will help you start developing new components in openIMIS